So we're talking about 4 different properties of gases. We've got the pressure of the gas, that's symbolized with a capital P. Volume is a capital V. The temperature of the gas, capital T, and the amount of the gas. And that's measured in moles because it's the number of particles that's important. These properties are interrelated. If you change one or more of the others will also change. And so we have a set of simple gas laws that describe relationships between pairs of these properties. And these were deduced a long, long time ago from observations where they would set things up so that 2 of those variables remained constant. They would change one and then observe the other one and see how it changed. So these laws are named for the people who discovered them. This is Boyle's law, Robert Boyle, back in the 1600s. I'm not going to ask you to remember their names, okay? But we're going to use their names. So, Robert Boyle, so he used a J-shaped tube, and he trapped a sample of gas over here. And then what he did is he added pressure here by adding more mercury. More mercury will increase the pressure on the gas. And what he found was that the volume of the gas got smaller. So higher pressure, smaller volume. That's an inverse relationship. This is what data from that experiment might have looked like. So here and this is millimeters of mercury, here at a very low pressure we have a high volume, and as we increase the pressure, the volume decreases. Well, that's a curve, and scientists prefer straight lines. So I'll show you that in just a minute. But this is how we can state Boyle's law. The volume is proportional to 1 over the pressure. So if we graph the volume versus pressure, we get a curved line, and that's what we saw here. Volume versus pressure. If we graph volume versus 1 over the pressure, we get a straight line, and that's shown here. So this is volume versus pressure. This is volume versus 1 over pressure. So you take the pressures here, and you take the inverse of those numbers, and then you graph volume and 1 over P. And this is when we hold the temperature constant and we keep the amount of gas constant. And so we derive this relationship, P1V1 equals P2V2. The pressure times the volume for that gas will be constant. If we increase the pressure, the volume will go down, the product will be the same. And so we can say that the pressure of the gas under the first circumstance times its volume will equal the pressure times the volume when we change something. Here's a molecular interpretation. So here we have the same number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 gas molecules in here, and here's a pressure gauge, and the pressure is 1 atmosphere, the volume is 1 liter. If we increase the pressure by adding more weight to the top of this cylinder, it's a movable cylinder like a piston, more pressure, then what we'll see is the volume will decrease. The volume decreased, the volume was cut in half, and the pressure was multiplied by 2. So 1 went down by 2 times 2, and 1 went up by times 2. Boyle's law can be applied to scuba diving. Here we have water pressure instead of atmospheric pressure. For every 10 meters of depth, you experience 1 additional atmosphere of pressure due to the weight of the water. So this diver is down at 20 meters. So up here the pressure is 1 atmosphere. You go down 10 meters, you add an atmosphere. So that's 2 atmospheres. Go down another 10 meters, and now you've got 3 atmospheres of pressure. This has some very practical consequences. If you're down at 20 meters, your lungs are experiencing a pressure of 3 atmospheres. If you were to take a breath and hold it and go quickly up to the surface, that would not be good for your health. Because as you go up, if you're not letting that pressure out, the volume of your lungs is going to have to increase by a factor of 3, which is not going to be good for you. So, when scuba diving, always exhale when rising. They don't have another one, do they? It's always bothered me that they put this kind of hard problem in as the example, but let's do it anyway. So this is kind of a critical thinking problem here. There's way too much story here. A snorkeler takes a syringe filled with 16 milliliters of air from the surface, where the pressure is 1 atmosphere, to an unknown depth. The volume of the air in the syringe at this depth is 7.5 milliliters. What is the pressure at this depth? And there's more questions. If the pressure increases by 1 atmosphere for every additional 10 meters of depth, how deep is the snorkeler? Okay, this is one where ugly pictures can help. So there's the surface of the water. And here's my syringe up at the surface. And the volume of air in the syringe is 16 milliliters. All right, there's the plunger. So, just for your fingers to hold on to there. So we take this down under the water, and what happens is that the volume of air decreases because of the external pressure. That's like pushing your thumb on the plunger. This is closed at this end, it's not open. When you push on this, you can compress the air. And then when you release, it's going to come back. Down here, the water is pushing on the plunger and causing it to compress. So down here, the volume is 7.5 milliliters. So this is a Boyle's law problem. Boyle's law, pressure 1, volume 1 equals pressure 2 times volume 2. Well, let's call this 1 because that's where it started. And we'll call this 2 because that happened second. So I have the volume at each. What's the pressure up here? 1. The pressure at the surface of the water is 1 atmosphere. And what they want us to find is the pressure down here. When we're working with gases, we're going to use the equations. So there will be dimensional analysis because the units don't always work out the right way. But for the most part, it's going to be using equations. So here we have our equation, and we want to find pressure 2. Right? Well, I should have, let's see. What is the pressure? Here we have 16 milliliters at 1 atmosphere, and then we have 7.5 milliliters. So what I'm trying to find is pressure 2. Rearrange the equation first, and then put the numbers in. So I need to have an equation where P2 is by itself. So I'm going to divide this side by V2. I'm going to divide the other side by V2. So pressure 2 equals pressure 1 times volume 1 divided by volume 2. And I've got all of these things labeled over here. So pressure 1 is 1 atmosphere. Volume 1 is 16 milliliters. Volume 2 is 7.5 milliliters. And the milliliters cancel out, leaving atmospheres. So 1 times 16 divided by 7.5. How many sig figs should this have? 2. So the answer to the first question is 2.1 atmospheres. So the pressure down here is 2.1 atmospheres. The next question is trickier. So the pressure increases by 1 atmosphere for every additional 10 meters of depth. So this is at 2.1 atmospheres. It started out at 1. So the change in pressure (2.1 minus 1), so that's a total of 1.2 atmospheres that it changed. So you get 1 atmosphere for every 10 meters. 10 meters for every 1 atmosphere, and you end up with 12 meters. Yeah. I was like, wait, it's supposed to be 11. That's this. I don't know what I was doing there. 2.1 minus 1 is 1.1 times 10, 11 meters. Any questions?